So this is Unit 6, Lesson 11 of our Pre-Calc 12 class. The lesson is called Hyperbolas. And of course, Unit 6 is called Conics. So what we're going to learn about in this unit is the shape of a hyperbola and recognizing it from its equation. And we're going to start learning some of the key features of a hyperbola, but not all. So a hyperbola, from our standard conic equation, this conic equation would be a hyperbola if a and b are opposite signs. So if a is positive, b is negative, or b is positive and a is negative. Either way. If a is negative, we have a y squared minus an x squared, like this right here. And so what that's going to create is a hyperbola, which is like two parabolas, one that opens up and an identical one that opens down. Identical except that, it opens down. The center is going to be HK. And then we have these two things called vertices and co-vertices. And so if you think about, remember back when we talked about ellipses, this equation of a hyperbola is very similar to the equation of an ellipse, except that instead of a minus sign, it'd be a plus sign. So if this is a plus sign, this would be the equation of an ellipse. And then A and B would kind of give you the height and the width of the ellipse. And so now it's the same kind of thing. We're going to look at that same A and B, except it's going to give us, since it opens up and down, B is going to give us the location of the vertices, and A is going to give us the location of something called the co-vertices. And we're not going to really unpack what a co-vertice does for us in this lesson, but we will in lesson 12, the next lesson. So stay tuned for co-vertices. It gets more interesting. But anyways, that's kind of what we have here. We can identify the co-vertices and the vertices just by adding B or subtracting B or A from the center. Alright, so now if the x squared term, like if our b was positive and our a was negative, we get an x squared term minus a y squared term. If we get x squared minus y squared, then what we get is a hyperbola that opens up to the left and to the right. Again, identical parabolas, except one's facing right, one's facing left. And now, since that's the case, our A values are going to tell us the vertices, and our B values are going to tell us the co-vertices, which is the opposite of when it opens up and down, right? So if it opens up and down, B is going to tell us, which is the number below the y. B is going to tell us the vertices, and if it's x squared minus y squared, then the A, the number below the x, is going to tell us the vertices. And then co-vertices or vice versa. Okay, and just keep in mind when you do your homework assignments on Delta Math always does A as the major vertice, or the major axis, just like with ellipse. So if you're looking at their examples, their way they show the answer is going to be slightly different than the way I'm showing you here. Okay, so if we want to do some examples, here's one. We have a y minus 1 squared over 25 minus x minus 2 squared over 16 equals 1. Well, we have a y squared minus an x squared, so this is definitely going to be a hyperbola. Since it's y squared minus x squared, it's going to be opening up and down. So I know that I gotta look at my center. If we have x minus 2 and y minus 1, then 2, 1 is our center. Since our y squared is divided by 25, then our b is 5. And since our x squared is divided by 16, our a is 4. Because 4 squared is 16 and 5 squared is 25. So because my center is at 2, 1, I can go up 5 or down 5. So that means add or subtract 5 to the y value of the center. And that'll give us the vertices of the hyperbola. And then if I go left or right from the center by 4, I get the co-vertices. So I'm going to add or subtract 4 to the x value of the center, and that'll give us the co-vertices. slow computer. Alright, so this example is another hyperbola. Since it's an x squared term minus a y squared term, I know it's going to open to the left and to the right. I know my center is going to be -4 and +4, just off of our h and k values. It says it opens left and right. The a value, the number below the x, is going to tell us where the vertices are. So if I go left or right from the center by 6, I'm going to get the vertices. So I'm going to add and subtract 6 to the x value of the center. So 2, 4 and -10, 4 would be the coordinates for the vertices of this hyperbola. If I go back to the center and I go up or down by 1, because my b is 1, if I go up or down 1, I'll get my we'll get the covertices. So we're going to add or subtract 1 from the y value of the center. So if we do that, we'll get -4, 5 and -4, 3 would be the coordinates for the covertices. Alright, so that's the first step for hyperbolas. We've identified some key features: the center, the vertices, and the covertices. In the next lesson, we're going to unpack a couple more key features, and then we'll kind of wrap it all together. And again, covertices are just this thing that we've mentioned, but we haven't really talked about the why. We'll get more into that in the next lesson.